number 1, a solution of 20-liter antifreeze and water is 40% strong. You want to increase it to 60%, so how much antifreeze should you add? Okay, so here's the strategy here. The chemical divided by the total fluid equals percent strength. The amount of chemical divided by the whole fluid is how strong a mixture of chemical is going to be. Okay, I do this in real life because I've mixed stuff to spray like the garden and the weeds and things like that, and I have to figure out how much chemical to add to the jug of water. I actually had to help the custodians figure out, also kind of using something like this, how to mix like the spray that they had to fog the classrooms with last year. They did that. Okay, so here's what's happening. Okay, I have a jug, and right now there's 20 liters inside this jug. There's 20 liters of fluid in there. 40% of this fluid is antifreeze. So right now, how much antifreeze is in there? How do you do 40% of something? What kind of math operation do you do? Add, multiply, divide, subtract. Which one? Multiply. How do you multiply 40%? 0.4. Okay, so that equals 8. So right now, this is the jug. %40 of it is made up out of antifreeze right now. Okay, you want to add, you're trying to add more antifreeze, and you're trying to make this solution stronger, but you don't know how much you're going to add. Okay, so here I go. Chemical. So the chemical started at 8. I had 8 liters of chemical, but then I'm adding more. I don't know how much I'm adding more. I'm adding more chemical. Total fluid. Well, I started with 20 liters of fluid. But does it make sense that as I add antifreeze, what's also happening in this jug? The 20 liters is also rising. So this is the chemical that would be in there, and this is the whole fluid, which is water and chemical all together. When I'm done, I want it to be 60%. So you could do 0.6, but I have a little bit of a probably easier way. I'm going to write that percent as a 60 over 100. Okay, you could do a 0.6, but then you're going to be doing math with decimals. So that's the only difference. Okay, there we go. I set it up. Now this is old stuff. How do you solve this equation? So we have two things. We say, should we cross multiply it, or should we common denominator drop it? Remember those two strategies. Which one do you think would go on this one? Which is the best strategy? Cross multiply or common denominator? Cross multiply? Okay, so that times that equals that times that. Okay, so I'm going to go like this. 100 times 8 is 800. Plus 100 times A. Okay, now I'm going the other diagonal. So 1200 plus 60A. Okay, that's the cross multiply. So solving this, I have one variable. So I'm going to do some isolation. Okay, I'm going to group together the A's. So I'm going to subtract 60A. Okay, I'm going to subtract 800. Keep going with your algebra. And divide by 40. So what does this all mean? It means that I should add 10 liters of antifreeze in there. So what will your solution... Yeah, you can do that too. Yeah. But when it's like a random percent, like a 68 or something, then you can always just know, I'm going to do it over 100. But yes, for sure. You can make that, or you could have done 3/5. Yeah. You got the same answer, right? Is that what you did? Yeah. Okay. So in the end of this, what does my solution look like? So altogether, I would have had 18 liters of antifreeze in this mix. Just checking my answer here. And altogether, my container would have 30 liters of fluid in it. Does that make sense? Altogether, there was 18 of the chemical part of it and 30 of everything. So that divided by that, we should get 60%, right? Okay. Next question. It takes Jeremy 20 minutes to push mow a yard. If Carl helps, it takes him 12 minutes. If Carl were to work alone, how long would it take him? Okay, so here's what we're going to do. Jeremy and Carl, we're going to talk about two items here called time and rate. Okay, so time is how long they work, and rate is how long it takes them all alone. That's a rate. A rate is something when you're doing it, how long does it take you to do the whole thing? Okay. So I want you to think about this, like if it takes you 4 minutes to run a race and 3 minutes has passed, you've completed 3/4 of the job, of the race. Does that make sense? So at that point, the 4 minutes would be your rate and 3 minutes would be the time that has elapsed. Okay, it takes Jeremy 20 minutes to push mow the yard. Would that be considered the time that Jeremy's working for or his rate to do a job? Rate. So Jeremy's rate is 20. Carl helps, so now they're working together. If Carl was to help, now it's going to take them 12 minutes. So that's going to be the time that they do it in. So they both are working, and so when they're both together, the time is 12. If Carl were to work alone, how long would it take him? So I'm trying to find Carl's rate. Rate is this when you're by yourself. Okay, so here we go. Jeremy does 12/20ths of the job because it takes him 20 minutes to do the job. So if he's working for 12 minutes, he has completed 12/20ths of it. Plus, Carl does 12/somethingths of the job. And the portion that Jeremy did plus the portion that Carl did is the entire job. This is the portion of Jeremy, the portion of Carl, but together they're doing the whole job, and the whole job is getting done. Okay, so that's the new stuff. Now we go old stuff. Am I going to cross multiply or am I going to common denominator both sides? So I'm going to have to common denominator this one. So what do we want to have as a denominator? I'm going to need a 20K. Okay, first fraction. This would have to get multiplied by a K. Second fraction, that would have to get multiplied by a 20. So that's 240. And do you understand that 1 is when you have the same thing over the same thing? Okay, so here's the setup. Once we say the bottoms are the same, now I'm just worried about the tops being the same. So I'm solving the top equation. Okay, so how do I solve something like that? I have one variable, so I'm going to isolate the k. So right now I'm going to subtract 12k. So if Carl worked alone, it would take him 30 minutes to do the yard. So he's slower than Jeremy. Okay, number 3. We're filling up a pool and we're using 3 hoses to fill up the pool. So that's what's going on. We're using 3 hoses and we're trying to fill up the pool. Okay, so this is a time and rate question here. So hose number 1, number 2, and hose number 3, the time and the rate. Okay, I'm going to read it and we're going to think about where to put it. If you just use the first hose, it would take you 10 hours to fill up the pool. So is that a time or is that a rate? That's a rate because it's how long it takes them to alone to do the job. So that's a rate. If you just used hose number 2, it would take 12 hours. So that's also a rate. And if you just used hose number 3, it would take 18 hours. So that's a rate. How long does it take when you put all 3 of them working together? So I want to know the time. And the time is going to be the same. The same time, because when they're together, when they've filled the pool, they've all been going for the same amount of time. Okay, so here we go. Hose number 1 does X tenths of the job, plus hose number 2 completes X twelfths of the job, plus hose 3 completes X 18ths of the job. This portion plus this portion plus this portion all add up to the whole job. They each do a portion of the pool. Together they do the full pool. Okay, you look at it and you say, should I cross multiply or should I common denominator? So this is a common denominator. All right, now we got to get a number. We need a number that we can divide by all of those. Somewhere between 100 and 200, I think we are going to find a number. Anybody get one yet? 180. 180 would work with all of them. Okay, so what did I do to the 10? I timesed it by 18. What did I do to the 12? I timesed it by 15. What did I do to the 18? I timesed it by 10. And how do you write 1 as a fraction? Whatever you have, it needs to look the same thing over the same thing. Oops, I forgot an X here. Okay, so at this point, the bottoms are already the same, so I'm going to make the statement that the tops have to be the same. I'm also going to put those together. So 43x equals 180. So divide 180 by 43, and you get 4.19 hours. Does that number make sense when you're filling up that pool? Right? It's obviously going to be faster to fill up a pool with 3 hoses. We're going to also assume that the water pressure is good. Okay, number 4. A boat travels 9 miles upstream in the same time it goes 11 miles downstream. The current of the river is 3 miles an hour. Find the speed of the boat. Okay, so let's get a little physicsy here. Sorry, velocity is like your speed, right? Velocity is like your speed in your car. How do you drive in your car? What do you always see in your car on the dash? What's the speed measured in? Kilometers per hour, right? So that's a distance divided by a time. Okay, if I wanted to rearrange this formula, what if I wanted to do that formula for distance? What would I write for distance? Distance is the v times t. I'm manipulating formulas. And then if I wanted to do time, how would I do time? You would have to flip the t and the v So D divided by V. Okay, here's what I know. The same time. So the time to go up is going to be the same time as you go down the stream. Okay, so I knew that my formula from that is going to be the distance over the velocity. Okay, so we're going upstream, and then we go down the stream. Okay, a boat travels 9 miles upstream, so that's going to go there, 9 upstream. In the same time, it goes 11 miles down the stream. Okay, the current of the river is 3 miles an hour. So when you're going upstream and downstream, what's the current doing? When you're going up the stream, is the current adding to your boat speed or subtracting to your boat speed? Subtracting. So this is upstream. It's the velocity minus 3. Because it's slowing you down. As you go up the stream, it's slowing you down. When you go downstream, what's the current of the river doing? It's adding. Does that make sense as a visual? When you go down the stream, now the current of the river is adding to your velocity. I felt like that this morning driving against the wind here on the highway. Okay, we're done that part. Now, old stuff. What do you want to do with this? Should we cross multiply or common denominator it? So I'm going to cross multiply. So 11V minus 33 equals 9V plus 27. And you could have done that opposite of what I did it, right? You could have done this first and then that. Doesn't matter. Okay, get your V's together. So subtract 9V. So I got the speed of the boat is going to be 30 miles per hour. So when it's going upstream, it's actually only going to be traveling 27. And when it's going downstream, it's actually going to be going 33. Okay?